Hello friends, last time we have discussed multiplexer circuit, its basic operations and 2 cross 1 multiplexer, 4 cross 1 multiplexer. We discussed its block diagram, truth table, Boolean expression, and we have designed circuits for that 2 multiplexer circuits. And also I have given one assignment, that is to design 8 cross 1 multiplexer circuit. I hope everybody did that assignment. Now today I'm sharing one video uh, all about multiplexer circuit with enable input. So here a multiplexer circuit will have one extra input in addition to what already we have discussed earlier, and that input is enable input. Otherwise its operation is same. The multiplexer circuit operation is same as normal multiplexer circuit. Means it is going to have 2 raised to n inputs and selection lines and one output line. So that is going to remain same. The only difference is that the circuit will have enable input. Now the purpose of enable input is it gives us one option whether to disable the multiplexer circuit or enable the multiplexer circuit. Enable means make it on and disable means making it off. So it is like a switch. So when the switch is on, at that time only the multiplexer will work. And if we are not allowing, means this enable is not proper, this proper signal is not given, that means the switch is off. At that time the circuit is not going to operate. So let us see in detail with the help of block diagram and truth table and everything. So first focus on block diagram. You can see it is similar to the normal multiplexer diagram we have discussed. It is having 2 raised to n inputs and n selection line. Here 3 selection line, S0, S1 and S2. So 2 raised to 3 inputs, so 8 inputs, that is D0, D1, D2, D3, D4, D5 and D6 and D7, and one output. Normally this is what we normally seen in multiplexer, but in addition to that we are having one more input, that is enable input, and we denote it as a E bar. Fine. Means it is a input or it is a switch. The signal which we supply here will work as a switch. So when we are supplying 0 over here, the multiplexer circuit will work. If we supply 1 over here, the multiplexer circuit will not work. It is active low input. It is active low. So if you want to make it on, you have to give input as a 0. Fine. If it is active high, then you should give 1. But in that case, this bubble is not present. Here the bubble is present, means it is active low input. Means when input 0 is given, at that time it will on this multiplexer. If 1 is given, so it is not going to select this multiplexer circuit to work. So this is enable input. Now let's see its truth table. Truth table is simple. You can see one addition column is added, which is enable column. I have denoted is a E bar, and selection line is there. There are 8 different combinations, 0 0 0 to 1 1 1, and output column is there Y, which is highlighting the output of the multiplexer circuit. Now you can see the first row of this truth table. You can see S2, S1 and S0. These all are XXX, means whatever it may be, but when the enable line is high, at that time the circuit is not going to work and output is low, that means 0. So nothing will be output because enable is high. Why high? High means 1. So when it is 1, the circuit is not selected for operation, means switch off, it is disabled. It will work only when you give low input. You can see the rest of the input combination. You can see for enable input is what? L L L L. L means low, low means 0. So when enable input is 0, at that time only it is going to work. If it is high, whatever the input is there, selection line is there, whatever the combination you give, it doesn't going to make any sense, and the output is always going to be 0. That means L. So this is the difference which it is making with the help of enable input. Otherwise it is similar. You can see 0 0 0 L is input, so enabled, and in that case output is D0. That means D0 line is transferred to output Y, like this, right? So that is known to you. Truth table is going to like that only, work like that only. 0 0 win, D1 will be high output, 0 1 0 D2 will be output, and at when likewise all combination will work, and it is 111 D7 will be considered as a output. It will be given as output by the circuit. So this is Boolean expression. Now it is changed little bit. We are having one more extra parameter, that is E bar. So S2 bar dot S1 dot bar dot S0 bar dot E bar dot D0 plus S2 bar next combination, and so on. We can have last combination like this, S2 dot S1 dot S0. I forgot to write over here E bar, so that is for last combination. Likewise you can have uh, different combinations in between over here. So this is Boolean expression, and from Boolean expression we can easily design multiplexer circuit, internal circuit of multiplexer. So yeah, I hope you have to do that, and also I request you to design, this is, you can consider it as assignment, design 2x1 multiplexer with enable input, design 4x1, design 16x1 multiplexer with